Good morning to all. Now, in the previous session, we discussed operations on discrete time signals. There are three operations: time shifting, time scaling, and time reversal. The first time shifting operations are discussed on discrete time signal. So now in this session, we are going to discuss the remaining two operations on discrete time signals. Now just look at, in the previous class we discussed time shifting. The remaining two concepts are time scaling and time reversal. These two topics are remaining. Now we are starting time scaling. Time scaling. As said earlier, time scaling operation will be on vertical axis in both cases, in continuous as well as discrete cases. So time scaling always on vertical axis. Time shifting has always been on time axis or parallel horizontal axis. Now time scaling. Now this is with respect to which one? Discrete time signals. All these operations are with respect to what? Discrete time signals. Now just look at, let us start. This is n, this is x of n. Now this is origin 0, 1, 2. This is minus 1, this is minus 2. This is equal to 3. Now, so how to sketch this one? This is the way of this. Now just look at. So this is the sketch of discrete time signal x of n with amplitude 3. What is the amplitude? Amplitude is equal to 3 with the amplitude. Now, as we said, in the continuous time signals, what we said, what you learned, if x of t is a signal, then x of alpha t is time scaling of the signal. There are two cases arise. If alpha is greater than 0 but less than 1, it is expanded. Expansion will be there. If alpha is greater than 1, this will be reduction. That means what? Compression or reduction. Compression of the signal. The same concept here we are also using. There will be no change in the concepts between continuous as well as discrete. Only the representation will be differentiating between these two. Now just look at. The same concept here we are applying for discrete time signals. Now let us consider x of n is a discrete time signal. If x of n is a discrete time signal, then x of some alpha n, that is called time scaling signal. Time scaling signal. Here alpha is called scaling factor. What is alpha? Scaling factor. This is called scaling factor. Alpha is a scaling factor. The same conditions apply. If 0 is less than 1, it is expanded. Expansion. If alpha is greater than 1, it will be compressed. Compressed. But here just look at, in any of the case, alpha is not equal to 0. Here also alpha is not equal to 0. Here one point we have to discuss. We are discussing that this is discrete time signals. So discrete time signals means what? Here in most of the cases, all these are applying on the integer numbers only. For example, just look at, if you take from this graph find x of 2n. X of 2n. What is the x of 2n? X of 2n means what? Here. Now we have to draw the x of 2n. The given width of the signal, actual signal width is equal to -2, -1, 0, 1, 2. with amplitude 3. Amplitude 3. Here 2n. 2n means what? The signal will be 2 is what? Greater than 1. Greater than means what? The signal will be compressed. Compressed means here we have to write that x of 2n, its width will be dividing everything 1 by 2, minus 1 by 2, 0 by 2, 1 by 2, 2 by 2, like this. There will be no change in the amplitude. So the resultant width will be minus 1, minus 0.5, 0, plus 0.5, 1. But this is discrete. Discrete always takes on what? Only integers. It never takes on decimal values. So here we won't consider, this we won't consider. Therefore we consider minus 1, 0, 1 only. Now therefore, what is the resultant sketch of this discrete time signal? This is n, this is x of 2n. Then what you have to make it? For example, this is minus 2, minus 1, 0, 1, 2. Now here what will happen? That is equal to 3. So here in compression means what to be compressed. In the previous case, look at the width. Width is from minus 2 to 2. But here minus 1 to 0. What is its 1? 3. Amplitude is 3. So the first one, integers required are minus 1, 0, 1, only 3. Just look at the given actual signal width contains 5 integers, 1, 2, 3, 4, 5. In the compression, 5 integers will be converted into 1, 2, 3 integers only. So minus 1. So here we have to start with, this is the next one, this is the next one. So among these three, look at, this is the center one. Next one, these two are of the same height. Now this is the signal. This is the compressed signal of this one. Compressed signal of this, the actual time scaling signal, compressed. In the same way, just you can go for by 2, you have to expand the signal. Then expand the signal means what? We have to multiply minus 4. For example, look at, in the same way, if you want to make it a signal of n by 2, for example, n by 2. Now, here n by 2 means what? Value less than 1. So, the actual sequence is what? X of n. So, x of n is equal to sequence minus 2, minus 1, 0, 1, 2. So, here x of n by 2, this implies, this becomes multiply minus 4, minus 2, 0, 2, 4. So now the new sketch of the graph will be like this. N, this is x of n by 2. Now the numbers look at, for example, this is minus 4, this is minus 2, this is 0, this is 2, this is 4. The amplitude is always same, 3. So how to draw this one? Look at. Now look at this one. The signal will be expanded. In this case, the signal is compressed. That is the operations on signals regarding time scaling. Now, the next concept is called time reversal. The next concept is called time reversal. Time reversal. Now just look at, in the previous case, if x of t is a continuous signal, then x of minus t is called time reversal. So here also, if x of n is a discrete time signal, then x of minus n is called its time reversal. For example, look at, let us consider a sketch of discrete time signal x of n like this. For example, this is minus 1, 0, 1, 2, 3. Amplitude is also 3. So the graph is like this. Now just look at, this is the signal of which one? X of n. Amplitude 3. This is amplitude. Now they may ask you, sketch the graph of what? X of minus n. So x of minus n is called what? Time reversal. Time reversal. Now just look at, in time reversal, same practice you have to follow. How did we make in the continuous time signal? So here also, what is the sequence of x of n given signal? The sequence is called minus 1, 0, 1, 2, 3. Now here x of minus x of n. Now just look at. Now it can be make it first. The first step is what you have to make it? Multiplying or reverse the values. 3, 2, 1, 0, minus 1. Now x of minus n means what? Multiply with minus all. Minus 3, minus 2, minus 1, 0, 1. Now look at, this is the sequence. In the previous case, it begins with minus 1. Ends with minus 3. Now in the new time reversal concept, it will be beginning with minus 3, ends with 1. So the same graph here, just we have to make it like this. Now just look at, this is the graph, this is n, this is x of, which graph we are making? Minus n, minus n. Here the points what you have to make it with minus 3, minus 2, minus 1. So here for example look at, this is minus 3, minus 2, minus 1, 0, this is 1, 2, like this. Amplitude is 3, same. Amplitude never changes. Now among this one, take the mid one. This reaches the amplitude level. The next two, look at, these two are same height. Next. These two make it same. Here. Next it is like this. These two are same height, these two are same height, these two are same height. So this is the sketch of time reversal of given discrete time signal. So now here one important point, just to have to make it like this. How many are there? Minus 3, minus 2, 1, 0, 1 only. Sorry, there is no 2. There is no 2, only 1. Now, so this is amplitude. So mid one is minus 1. So this minus 1 reaches the amplitude level. Next one, these two are same. Next, these two are same. Now just look at, that is the signal, because here 1, 2, 3, 4, 5 sequence numbers. So 1, 2, 3, 4, 5 sequence numbers are there. So this is the graph of x of minus n. You take any graph like this, that is. One more small example. For example, look at, this is n, this is x of n. The given signal is, for example here, for example 4, 5, 6. Amplitude is 2, for example. That means what? The graph will be like this. Like this. Now, what is x of minus n? So the given sequence is x of n. The given sequence x of n is equal to what? 4, 5, 6. Now x of minus n, just multiply with reverse and multiply with minus, reverse. Minus 6, minus 5 and minus 4. So now we have to make it this graph as, now just look at. Here for example somewhere minus 6, minus 5 and minus 4. amplitude is equal to 2, same amplitude, so the graph will be like this. This side, reverse, replica, reverse. In the same way, just you can make it, for example, look at, this is n, this is x of n. The graph can be, for example, -4, -3, -2, amplitude equal to 3. This is the graph, sketch of a discrete signal. What is x of minus n? What is x of minus n? So x of minus n could be which one? Like this. So this is n, this is x of minus n. Now here what the sequence? The sequence is equal to -4, -3, -2. So the new sequence will be what? Multiply with reverse and multiply with minus. So the new sequence will be 2, 3, 4. So here it will be 2, 3, 4. Amplitude will be 2. So the middle reaches this one. The next are of the same height. Now just look at. This is -4, -3, -2. In the reverse way, 2, 3, 4. So these are the sketches of discrete time signals. So in this session, we discussed all the 3 operations on signals, on both continuous time signals and discrete time signals. We also learned that how to sketch discrete time signals and how to convert discrete to time and time to discrete as well. Thank you. In the next session, we'll be continuing.